Hello everyone, welcome you all at Lokesh Sir Unlimited Study Zone. So, students, we have completed all such categories of derivations related to spherical and is spherical refracting surface. Okay, it may be concave, it may be convex. The final image is on the virtual medium, or final image is on the rarer medium or denser medium. Sorry, not is virtual. So, finally, we have derived the formula. We have two formulas here actually. Okay, and actually mainly there are two type of refractions take place. First is when the refraction is from when your final image is formed on denser medium. Yes, and when your image is real. Two things are there. The category is refraction from rarer to denser medium. Yes, this is the important line. Refraction is from rarer to denser medium. It means your final image is on denser medium. Then what is the formula? You have to remember this formula like this. You have to read it like this. The formula is mu2 upon V minus mu1 upon U equals to mu2 minus mu1 upon R. Okay, this is your formula. Very, very important. Mu2 upon V minus mu1 upon U equals to mu2 minus mu1 upon R. Check here the formula equals to, in the place of mu2 here, we have taken N2 upon V minus N1 upon U, or mu1 upon U. You can write this like this also. Yes, so you can write this one as first it is N2 upon V. So you have to write mu2 upon V minus mu1 upon U equals to mu2 minus mu1 upon R. Clear? R is the radius of curvature of the spherical surface. Okay. And this is only for when the refraction is taken place from rare to denser. Means your final image will be formed on the denser. Okay. So make it a point. This is VIMP, rarer to denser, rarer to denser. Okay, your final image will be formed on denser medium. Okay, see when the refraction is taken from air to glass, air to glass. Clear? So mu1 equals to mu air. And you know the air refractive index of air equals to 1. And mu glass having some refractive index, consider it mu. So for the particular cases, air to glass, you have to write the formula. It will be mu upon V minus 1 upon U equals to mu minus 1 upon R. Okay. For numerical air के लिए, for air mu1 equals to 1. For air, mu1 equals to 1. Clear? So this become your first derivation. Now, second category we have derived, that is refraction taken place from denser to rare. Yes. So D to R means your final image will form on a rarer medium. Then what are the relations? Must remember them. You just change the value here. In the place of mu1, you have to place mu2. And in the place of mu2, you have to place mu1. Okay. So here it will be mu1 upon V minus mu2 upon U equals to mu1 minus mu2 upon R. Yes, check here. Mu1 upon V, here the see N1 upon V. So N1 upon V means mu1 upon V minus N2 upon U means mu2 upon U equals to mu1 minus mu2 upon R. Clear or not clear? Okay. So write these formulas together. You will be have a better understanding. For air, for mu air equals to 1. For numerical purpose, you have to put mu air equals to 1. So it will be 1 upon V minus mu upon U equals to 1 minus mu upon R. Clear? So this is for denser to air. Okay. So what formula we have read out? Mu2 upon V minus mu1 upon U equals to mu2 minus mu1 upon R. This is from for rarer to denser. Okay. And mu 1 upon V minus mu 2 upon U equals to mu 1 minus mu 2 upon R. This is for denser to rarer. Clear? Okay. Most of the numericals has been asked from these for two formulas. Okay. And we have to use these formulas for lens making formula. Next. Clear? Should we continue, students? Okay. So next topic is uh, our next topic is lens. Yes, lens. Lenses. So this is the definition of lenses. A lenses is a transparent refractive medium bounded by the two spherical surfaces, or one is a spherical surface and another one is the plane surface. Okay. Lenses are the divided into the two classes, convex or converging lens. Yes, first is convex lens and it is also called converging lens. A convex lens is that which is thicker in the middle and thin at the edges. These lenses are of the three types. This is called double convex lens. When the both of the faces of the convex lens are convex, then this is called double convex or biconvex. Check here. This lens, the opposite part, the outer part here is convex. Clear or not clear? And this the another part is also convex. So the this lens having two faces L1 and L2. So this is called biconvex lens. Clear or not? And if both the faces are concave, then this type of lens is called biconcave. Generally, we use the word concave lens, but its pure name is biconcave. Clear? So these having two faces. Check here. There it would be two center of curvature. For L1, the part of L1, center of curvature will be lying here. This is supposed to be C1. And here it is L2. Is the center of curvature will be C2 will lying here. Clear or not clear? Okay. So, yes. Concave. See, this is double convex. This is plano convex. One of the face is plane and on that another face is convex. So it is called plano convex. And this is concave and convex. So it is called concavo convex. Next, concave or diverging lens. A concave lens is the thinner at the middle. Yes, this lens is thinner at the middle. Okay, and thicker on the walls outer side at the edges. These lenses are of the three types. This is called double concave, this is plano concave, and this is convexo concave. Okay, the main part is concave. Over that, there is a convex lens. So this is called convexo concave. Important terms related to the lens. Now, this is important thing. Principal axis. What is principal axis? So it is defined as the straight line that passing through the center of curvature of the two surfaces of the lens. As we have to discuss only with the type of lenses, that is double convex and double concave. So first it is um, optical axis. So what is optical axis? Check if there are two center of curvatures. Yes, there are two center of curvatures. Then an imaginary line is passing through these two center of curvatures. This is C and C dash. Clear? So this imaginary line is passing through these two center of curvature is called what? Optical axis. Clear, beta? Similarly, for the convex lens, also biconvex lens, there are two center of curvature, and this imaginary ray is called optical axis. Done. Principal axis. Okay, it is also called optical axis. In the case of lens, it is also called optical axis. So it is defined as the straight line that passing through the center of curvature of the two surfaces of a lens. Done. Optical center, yes, it is taken as the point lying on the principal axis so as a ray of light passing through it does not suffer any deviation from its path and it undergoes undeviated without any lateral displacement. Check what is optical center. The optical center is the point. within or outside the lens at which incident rays refract without deviation. Yes, so this is called the center point of the lens is called optical center. And remember, if a ray coming to the optical center, then it will go undeviated. Clear? It will go undeviated. Any problem? Hmm. Next is, yes, done. So this is optical center. Next, it is very important that principal axis, principal focus. This definition is very important, students. Principal focus. Try to understand the concept of principal focus. When a beam of light is incident in a lens in a direction parallel to the principal axis of the lens, the ray after refraction through the lens converge. In the case of convex lens, it get converged or appear to diverge in case of convex lens from a point on the principal axis. This point F is known as the principal focus of the lens. Yes, in lens there are two focus. One is called principal focus and another is called secondary focus. You have to, your principal focus is your supposed to be main focus. And what is the definition of principal focus? When a light ray is coming parallel to the principal axis, these are the light rays coming parallel to the principal axis, and after the refraction they imposed, you can say, yeah, they collected at a point. That point is called principal focus of the lens. Clear? The rays coming parallel to the principal axis after the refraction, they converges or appear to diverge from. They converges at a single point, at a fixed point. So this is called principal focus. And the distance from the optical center to this focus point is called focal length. So beta, this is called your focus. It is called F2. This is called F2. In the case of lens, convex lens, this is called F2. Clear? Because the reason here is called 2 and the reason here is called 1. So it is on the second side. So this focus is called F2. So which is the main focus? Which is the main focus? F2 is the main focus. Secondary focus is the main focus in the case of convex. Clear or not clear? Now here, check here. The rays coming parallel to the principal axis, they are get diverges or appear to be diverges, appear to be coming. Now these are the rays are getting diverged, and on extending them behind, they are appear to be come from this point. So this is called principal focus of concave lens, and this is on the first side. So it is called F1. So which is principal focus? F1 is principal focus in concave lens. Clear? Now check the focal length for the convex lens is negative as it is on the right side. So convex lens, for convex lens, that focal length is positive, f equal to positive, and for concave lens focal length equals to negative. Clear or not clear? So if for the convex lens, second focus will be a main focus, and for the concave lens, first focus is like a main focus. Done. Make these two diagrams. Clear? Mhm. Make these two diagrams. Yes, what? Principal focus. These focus are called principal focus. However, there are two focus for a given lens. You have to consider these focal focus as a main focus. So whenever you have been asked for the focal length of a convex lens, it will be positive, and focal length for a concave lens is always negative. Okay. Now check first principle focus. First principle focus means here first principle focus for the convex and first principle focus for the this is for convex and this is for concave. So first principle focus in for convex lens, first principle focus is main focus. Okay, in which one lens? Concave. Okay, so wait. Okay, try to understand the definition, then you can clear. First principle focus. It is the point on the principal axis of the lens. The rays of starting from this point in a convex lens or rays directed to this point in a convex lens become parallel to the principal axis. So this is the different thing. Okay, this is not the previous one we have read out. In the previous cases, the lens, the rays coming parallel to the principal axis after the refraction passing through a point. That is called your principal focus. But here, the rays are coming from that point and after the refraction getting parallel. So that is called first principal focus. Check here. Here the focal length of the convex lens is equals to negative. For the f1, focal length for the convex lens equals to negative. Clear or not clear? As it is first principal focus. But here it is the real focus. Second principal focus is the real focus. The rays coming parallel to the principal axis after the refraction, meet at a point, that focus is called your second principal focus. So f2 here is equals to positive. Clear or not clear? So here f2 is equals to positive and f1 for the convex lens equals to negative. Check here. F1 for the concave lens is positive and f1 for the concave lens is negative. Okay, for so yes, f1 for the concave lens is positive and f2 for concave lens is negative. So our second principal focus is considered as a main focus. In the numerical, we have to consider only second principal focus as a main focus. Okay. Main difference is that two lines, the difference of two lines. First, the point from where the light comes after the refraction getting parallel to the principal axis. This is first thing. The rays coming from that point after the refraction they getting parallel is called your first principal focus. Clear or not clear? See here for the convex this is looking like this, and for the concave the rays coming from a point after the refraction they getting parallel, so these are called first principal focus. Clear? And second principal focus, that is supposed to be main focus, the rays coming parallel to the principal axis after the refraction meeting at a point or appear to be meet at that point for concave or appear to meet at some point, that is called your second principal focus. So here it will be f2 and here it will be f2. You can check the focal length of the second principal focus will be positive for the convex and it will be negative for concave, and first principal focus it is negative for convex and this would be, this has to be positive. I have made something wrong. The rays getting parallel coming. Yes. After the reflection they have to be parallel. Yes. Okay. So they getting parallel. So virtually they have to meet some point. So this is called your what? First principal focus, F1. Clear? This is neat and clear diagram. So understand what is the basic difference. In the first principal focus, there is a point, emphasizing the point from which the ray is coming to the lens after the refraction getting parallel. And in the second case, when the rays are coming parallel to the principal axis after that refraction, they focusing at a single point, that is called second principal focus. Clear? Okay. So both the focus of convex lens are real, while that concave lens, the focus are virtual, and we always use a second principal focus. Yes, we have to use only second principal focus. So remember, for the convex lens, second principal focus distance is positive, and for the concave it will be negative. Clear, students? Yes, let us see the next very important formula of this chapter, lens maker's formula. And before that, aperture. What is aperture? Aperture of a thin lens is the effective diameter of its light transmitting area. So this is the aperture. Like this is a lens. So this part is called aperture. Clear? This part is called aperture. Okay, so let's start. Very most important formula of this chapter. Highest demanding formula. Okay, most times asked in the examination, that is lens maker's formula. So what is lens maker's formula? It is the relation connect focal length of a lens to the radius of curvature of the two surfaces. Like here, this is a lens. So now these lens having what radius of curvature? First, this part having radius of curvature as R1. It having some center, this part. So this is supposed to be R1. This part also having some radius R2. So the lens having two radius of curvature. So this formula connect the focal length of a lens to the radius of the curvature of the two surfaces of the lens, and the refractive index of the material of the lens. Means you have to derive a connection between R1, R2, mu1, mu2, and focal length. Clear or not clear? Clear or not clear? Yes. So there will be a lens. The outside medium is considered as mu1. The inside medium of the glass is considered as mu2. This is the focus, the center of curvature here is C2, and here the center of curvature is C1. So the radius of curvature up to here is R2, radius of curvature here is R1, and the relation between all the things, and also focus. So focus will be here. Yes, this is the focal length, main focus. The relation between these all the parameters is called lens maker's formula. Let us start lens maker formula. The lens maker formula is useful in designing lens for desired focal length using suitable material and surfaces of suitable radius of curvature. Clear? Actually, better the lens maker's formula will be, you will see f1 upon f equal to mu2 minus mu1 upon r, uh, mu2 minus mu1 upon mu1, 1 upon r1 minus 1 upon r2. Yes, we are going to derive this, so you can understand what for what purpose we can use for lens makers formula. If we have to make a lens of any focal length, so you have to design your lens by using this formula. Clear? So by taking a proper radius of curvature, you can have any focal length. Okay. So you can make a lens of any focal length, of desired focal length, using suitable material and surfaces of suitable radius of curvature. Fine. Now, Cartesian sign convention, same as before. Okay, when you're moving towards the direction of ray, that will be positive. Opposite direction of the ray, that will be taken as negative. Above side of the axis, it will be positive. Downside, it will be axis. All the distances will be measured from the optical axis and so on. Right? For a convex lens, f is positive, and the concave lens, f will be negative. Clear or not? Now, important assumption. As optics is full of assumption, here also you have to consider some assumption during the derivation. The lens is thin, so the distances measured from the poles of its surfaces can be taken equal to distance from the optical center of the lens. Now, what is this means? Like there is a distance We have measured from here, P to F. Clear or not clear? As aperture is very small, so this distance is considered as O to F. There is no difference between O and P. Okay, so consider PF is about OF. Understood? Hmm. Yes. Second point, the object consists only a point lying on the principal axis of the lens. Means you have to consider the object as a point object that will lie above the principal, that will lie on the principal axis. Fine. The aperture of the lens is very small. Yes, I already inform you. We have to take the aperture of the lens is very small. And next, the incident ray and the refracted ray make a small angle with the principal axis of the lens. Yes, as the aperture is very small, so the angle made by the incident ray and refracted ray we have to take very small. Now come to the next page, page number 43, and start with the derivation. Derivation for lens maker formula for convex lens. Yes, this is important derivation, most obvious, most time, many time asked question. Now, a convex lens is made up of the two convex spherical refracting surface. Yes, there are two parts in a convex lens. Try to understand A part and B part. First part is A and second part is B. So there will be two times refraction will takes place. So a convex lens is made up of the two convex spherical refracting surfaces. One is on left, one is on right. Everyone knows this is made up of two parts. So the final image is formed after the two refractions. Yes or no? How many times of refraction will place? Two times. One from the leftward and one from the right side. Clear or not clear? So student, make a clear diagram of this one in your copy. So first, what is O? O is the point object here. Yes, O is the point object, and the distance of the point object from the center optical center is equals to U. Optical center, your first distance of object equals to U. Now, yes, first refraction will be taken from the left face. Yes, try to understand. First refraction, the first image that is made by the first phase A, that is I1, that is intermediate image that is made by first phase, okay, leftward phase. So there is the intermediate image I1 and distance of this image is equals to V1. Yes, make it clear, very clear, V1. So V1 is I1 is what? Intermediate image. Intermediate image. Make there a bracket and name it. This would be intermediate image. This is intermediate image. Okay. Made by the left part of the lens. Made by left part of the lens. Okay. You can understood. It is clear that in the first formation of this intermediate image, the the rays are coming from rarer to the denser medium. From rarer to the denser medium. This means here it is a refraction from dense rarer medium to the denser medium as ray of light is coming from rarer to the denser medium. Now, second case. For the second case, this intermediate image I1, for the second case, this intermediate image I1 behave as a object, behave as a object for the right face, for the right one face, face B. Okay, and forms a real image I. So this is the final image I. So for image I, what for image I, this I1 behave as a object. For image I, this I1 behaves as a object, and here the refraction is takes place from denser medium to rarer medium. First refraction taken place from rarer to denser, and the second refraction taken place from denser to rare. Got it? Yes. So now referring to the theory in the figure P, yes. You have made the diagram. Everyone made the diagram. I1 and I. Clear? And I is the distance. I is the final image. So distance between C to I will be V. Distance between C to I. C to I. Center to image equals to V. This is your final image. Clear? Okay. Yes, coming to the theory in figure, check the figure. P1, P2 are the poles. Yes, these are the poles. C1 and C2 are the center of curvature, okay, of the two surfaces. Rightward it is C1 and left side it is C2. Of the center of the curvature of the two surfaces of the thin convex lens XY. The name of the convex lens equals to XY with the optical center O. Let mu2 be the refractive index of the material of the lens. Okay, so take the refractive index of the glass part as mu2 and the outer part as mu1. Yes, mark there. Inside the glass, you have to take the refractive index as mu2 and outside it is mu1. So let mu2 be the refractive index of the material of the lens and mu1 is the refractive index of the rarer medium around the lens. So there are two medium. Clear or not? Okay. Consider a point lying on the principal axis. O. Make there a point O. The name of the point is O. Consider a point O, point object O lying on the principal axis of the lens. A ray of the incident light is starting from the point O and incident normally on the surface XP1Y along the OP1 passing straight. So make a first ray that is passing through the optical center that will go undeviated. Yes, straight line. Take a through straight line from the center that will be go undeviated. This is first ray. As we need two rays, so we have to pass the first ray from the center, optical center. Now, the second ray, yes, optic passes straight. Another ray incident on the XP1Y. Yes, this is the left one surface along the OA and refracted along AB. Yes, check here. This is the first ray, second ray. This is incident along OA. Okay. And you know, when a ray coming from rarer to denser medium, it is bent towards the normal. So it will be bent towards the normal and passing through AB, you have to extend this ray and till your ray will strike on the principal axis and there will be your image I1. Yes, image I1. So this is your first image formed by the first refracting part. First refracting part of the lens X. Clear? Okay, so you will have your intermediate image now I1. Now I'm reading this para again. On the ray incident on the XP1Y along OA is refracted along AB. If the lens material were continuous and there were no second surfaces, so XP2Y of the lens, the refracted ray AB would go straight meeting the first refracted ray at I1. Therefore, I1 would have been a real image formed after the refraction XP1Y as the refraction occurs from rarer to denser medium. So we can write, yes. Now see what I am going to write here. Check the refraction in your diagram. Here in this refraction, the rays is coming from rarer medium and the refraction is taking from denser medium and there will be here you have your image I1. So your first formula that we have studied very in the start of the class, refraction from rarer medium to denser medium, what was the formula? It was mu1 upon V minus mu2 upon U equals to mu2 minus mu1 upon R. Yes or no? Mu1 upon V minus mu2 upon U equals to mu2 minus mu1 upon R. This was the formula. So use this formula here. Yes, mu1. Yes, first medium is mu1, no problem. What is V? V is here V1. Yes, the image distance equals to V1. So in the place there will be V1 minus mu2 upon U. So U is leftward. So you have to place it minus U. Mu2 upon minus U equals to mu2 minus mu1 upon R1. Mu2 minus mu1 upon R1. Okay. Yes. So mu2 minus mu1 upon R1. So here the that R1 is equals to R because the it is right side our center of curvature is on C1 is right side. So this is equals to R, capital R. So solve it, it will become mu1 upon V1 minus minus becoming plus mu2 upon U equal to mu2 minus mu1 upon R. Yes. So mu1 upon V1 plus mu2 upon V1 mu2 upon V1 minus mu1 upon U equal to mu2 minus mu1 upon U equal to mu2 minus mu1 upon R. Yes, we don't have to value of actually we don't have to wait. Okay, students, see here we are performing the first refraction from this surface, the left one surface, okay, the red one surface. I just colored it red. So the formula is equals to the formula from rarer to denser medium refraction equals to mu2 upon V minus mu1 upon U equals to mu2 minus mu1 upon R, right? So here mu2 in the place of V, there it will be V1 because the distance of the image equals to V1. So mu2 up है ना, mu2 upon V, it will be mu2 upon V. For formula rarer to denser, yes, we have studied it. Check the formula. Here it is. Yes. Yes. Formula is mu2 upon V minus mu1 upon U equals to mu2 minus mu1 upon R. Clear or not clear? So you have to apply this one formula. I am writing it again. Mu2 upon V minus mu1 upon U equals to mu2 minus mu1 upon R. So for the left surface, we have performed the refraction here. So what happened? Mu2 upon V. So in the place of V, there is distance of this intermediate image I1. We have considered it V1. So place here mu2 upon V1 minus mu1 upon U equals to mu2 minus mu1 upon R. Clear or not clear? Give it equation number 1. Done? Given? So this is the first part, mu2 upon V minus mu1 upon U equals to mu2 minus mu1 upon R. And this becomes the same result we have mu2 upon V1. You can write it also this one like mu2 upon V1 minus mu1 upon U equals to mu2 minus mu1 upon R. Agree? Yes. So now actually, these lens material is not continuous, therefore refracted ray AB suffers further refraction. We have seen so far the first part of refraction from this phase. And there is a reflection from rarer to denser medium. Now, again, there is a refraction from what? Now, your image is finally in denser medium as it is intermediate image. Finally, there will be a refraction from denser medium to rarer medium because the final ray find its image, formed its image on the rarer medium. So once again there will be a refraction from denser medium to rarer medium by the another phase, second phase. Clear or not clear? Yes. So we have to write again the formula for the refraction from this rightward surface. So actually, the lens material is not continuous. Therefore, the refracted ray AB suffers further refraction at B and emerges along the final path BI. Yes, check here. Where is BI? I am talking about this BI. This BI because of again refraction from this face, the outer face, the right one face. Okay. BI. Meeting actually the principal axis at point O. Therefore, I is the final real image of the point O, and this point I is your final real image of point O. This is the final real image of point O. So this will be the distance V, final distance V. This was intermediate image, so we have considered it V1. But now For formation of this image, this V1 will act as your object. Now this image, intermediate image, will act as object for the second phase. Clear or not clear? So it will be act as your object. Clear? Check here. For the refraction at the second surface, x p2y. Where is x p2y? The above part is x, the center one is p2, and the below one is y. The second phase x p2y, we can regard I1 as virtual object. Yes, important. So this I1 is virtual object whose real image is formed at I. Okay, and C I1 equals to V1, that is your object, and let C I equals to P2I, that is equals to V, and let R2 be the radius of curvature of the second lens. So we have the first radius of curvature as R1. So we written here the formula mu2 minus mu1 upon R1. No problem, make it R1. This part is R1. Okay, don't write it R, take it R1. And the second phase here for this one, this is center of curvature C2. So it will called R2. Clear or not? Okay. So write the formula. Now the refraction is taking place from denser to rarer, denser to rarer. So we have discussed the formula for denser to rarer. What? Mu1 upon V minus mu2 upon U equal to mu1 minus mu2 upon R. Or you can just change in the place of mu1 to mu2. Okay, so better here to change mu1 and mu2. So second time refraction for phase x p2 y. Yes, for the second phase, I am talking for this phase, refraction from this phase x p2 y, x p2 y, right? So we are going to perform reflection from this phase x p2 y. Formula, place in the place of mu2 there will be mu1. So here mu1 upon v. So what is final image here? V is your final image. Clear or not clear? Mu1 here. Now minus interchange mu2 upon u. Mu2 upon u. So what is u here? You know this is your u. V1 is becomes u. Yes or no? V1 becomes u because check here. The final lens form the image of this intermediate image. So this behave like object. So u becomes u, in the place of u, you have to place V1. Clear or not clear? This behave as a virtual object. So you have to place here V1. Clear or not clear? And finally, and again interchange mu1 minus mu2 upon radius of curvature as R2, and R2 is negative side, so you have to place it minus R2. Okay. Hmm. So mu1 minus mu2 upon R2. Mhm. One thing. Only plus R2 here. No need to place it minus sign. Mu1 minus mu2 upon R2. Because we already have used sign convention before. When the time we have made this formula, we already have taken the use of sign convention. So no need to write here any sign. Just place the values. Got it? Okay. When we have derived this formula, that time we have already used the sign of R1 and R2, so no need to put their sign. So this is equation number second. Now this becomes equation number second. Okay, let us check the formula. So it is mu1 upon V. Yes, find mu1 upon V minus mu2 upon V1. Mu2 upon V1 equal to mu1 minus mu2 upon R2 equal to mu1 minus mu2 upon R2. Fine. Now add the equation first and second. Add the equation first and second. So by first plus second. Okay. So till now what we have done, I am once again summarize. Now first what happened? There is medium outside mu1, inside it is mu2. So for the first refraction, this like reflection from the first surface, Your object distance is becomes u, the point object, and your final image equals to v1. So by the formula, mu2 upon v minus mu1 upon u equals to mu2 minus mu1 upon r1. You just place all these value. Mu2 upon v1 minus mu1 upon u equals to mu2 minus mu1 upon r1. So this was your equation number 1. And after then second, this V1 becomes your object and final image is given by the second surface at the place of I, I image here V. So you just interchange. So mu1 upon V minus mu2 upon, in the place of U there would be V1 equals to mu1 minus mu2 upon R2. Clear or not? This we have done till now. Now we have to add the equation number 1 with equation number 2. Okay, so by 1 plus 2. Okay, by performing first plus second. So what is first equation? We have this one, mu2 upon v1 minus mu1 upon u. Mu2 upon v1 minus mu1 upon u equals to mu2 minus mu1 upon r1 plus mu1 upon v minus mu2 upon v1 equals to mu1 minus mu2 upon r2. Clear? Now add them. You check this term and this term are same, having different signs, so they will get cancel each other. Here it will be mu1 upon v minus mu1 upon u. Yes or no? Equals to mu2 minus mu1 upon r1, mu2 minus mu1 upon r1 plus mu1 minus mu2 upon r2. Clear beta? So mu1 upon v minus mu1 upon u. So mu1 you can take common. 1 upon v minus 1 upon u equals to, you check please, mu2 minus mu1 upon r1. If you take minus sign common from here, it will become mu2 minus mu1. No. Here it is mu1 minus mu2. Mu1 minus mu2. So it will become mu2 minus mu1 upon r2. Yes or no? We have taken common a minus sign here. So mu2 becomes positive, mu1 become negative. Now total take common mu2 minus mu1 as a common. So it will be here 1 upon r1 minus 1 upon r2. Okay. So what? Mu1 1 upon v minus 1 upon u equals to this one. So 1 upon v minus 1 upon u equals to mu2 minus mu1 upon mu1, 1 upon r1 minus 1 upon r2. Clear? So make it distribute 1 upon v, 1 upon v minus 1 upon u equals to mu2 upon mu1 minus 1. Distribute mu2 upon mu1 minus mu1 upon mu1 becomes 1. 1 upon r1 minus 1 upon r2. Okay? Yes. This you can also write as 1 mu2. Okay? This is equals to 1 mu2. So 1 upon v minus 1 upon u equals to 1 mu2 minus 1, 1 upon r1 minus 1 upon r2. Clear? Hmm. So check, this is equals to 1 upon v minus 1 upon u equal to mu2 minus mu1 minus 1, 1 upon r1 minus 1 upon r2, where it is equals to 1 mu2 refractive index of the material, second medium with respect to first medium. Clear? Hmm. Now, when your object is at infinity, you know, in a lens, we know that is, give it equation number 1 and make a special note here. For a lens, when your object is at infinity, yes, when your object is at infinity, you know your final image is at focus point. Yes or no? Your final image is at focus point. Means when u equals to infinity, we can put v is equals to f. Okay. For u equals to infinity, v equals to f. So by equation number 1, by first, use this concept. By first, we have 1 upon v minus 1 upon u equals to what there is mu 2 minus mu 1 upon mu 2 upon mu 1 minus 1. 1 upon R1 minus 1 upon R2. This was. Now put here, in the place of V, there is equals to F. In the place of U, there equals to infinity, equals to mu 2 minus mu 1 upon mu 1, 1 upon R1 minus 1 upon R2. Now 1 upon f, 1 upon infinity becomes 0. Mu 2 minus mu 1 upon mu 1, 1 upon r1 minus 1 upon r2. Clear or not? So 1 upon f equals to your final derivation comes out. This is mu 2 minus mu 1 upon mu 1, 1 upon r1 minus 1 upon r2. Okay? Or you can also write this 1 upon f equals to mu 2 upon mu 1 minus 1, 1 upon r1 minus 1 upon r2. This is your lens maker's formula. Yes, check it out. Yes, see here, u equals to infinity. Okay, v equals to f, that is focal length. So is 1 upon f equal to 1 mu 2 minus 1, that is mu 2 upon mu 1 minus 1, 1 upon r1 minus 1 upon r2. Fine. Okay. Student, you can also write like this. 1 upon f equals to, this become 1 mu 2 minus 1, 1 upon r1 minus 1 upon r2. Yes. This lens makers formula. Clear? Now, student, next is lens makers formula for concave lens. So it will be same. It is the same formula for lens maker formula for the convex lens, means they are having both the formulas are same. Doesn't matter it is convex or concave. Clear? Hmm. So write it, derive it properly, and so many numericals are there for the case of convex and convex concave lens. Clear? Okay. Now next is lens formula. So we have two derivations here. Mhm. Check here, lens makers formula and then lens formula. We have formula this one as formula number A. This is formula number A. By A, we have 1 upon V minus 1 upon U equals to mu 2 minus mu 1 minus mu 2 upon mu 1 minus 1, 1 upon R1 minus 1 upon R2. So now we are going to derive lens formula. Lens formula. Okay. So by that complete derivation from start to end, we got what? We got this one. 1 upon V minus 1 upon U equals to mu 2 upon mu 1 minus 1, 1 upon R1 minus 1 upon R2. Clear? So by equation number 1, we have 1 upon V minus 1 upon U equals to mu 2 upon mu 1 minus 1, 1 upon R1 minus 1 upon R2. Yes, this one. This is equation number 1. And finally, this one formula and 1 upon F equals to, same formula we have got 1 upon F equals to, this is equation number 2. Yes. This is equation number 2. So you can write by equation number 2, by equation number 2, we have what? 1 upon f equals to mu 2 upon mu 1 minus 1, mu 2 upon mu 1 minus 1, 1 upon r1 minus 1 upon r2. Yes or no, student? We just have derived these two equations. This is equation number 2 and this is equation number 1. Agree or not? Now just divide 2 by 1. Okay, we have to derive 2 by 1. Now if you 2 divided by 1, so in the equation 2, I or otherwise you can compare 1 and 2. No need to divide it also. Right, compare first and second. You check the right part of both the equations are same. So if the right part are same, then left part are also equal. So 1 upon F equals to 1 upon V minus 1 upon U. This is what? This is Lenz's formula. Clear? So this is the derivation for the Lenz formula. This means to derive Lenz formula, you have to derive first the Lenz maker formula. Then you have to take this case. Then after you have to compare the right part and left part. And finally you will have your Lenz formula. Clear? So we have derived Lenz maker's formula and then thin Lenz formula. This is equals to 1 upon V minus 1 upon U equals to 1 upon F. Clear, Nitin? Done.